Water can exist in 3 different states. In the iceberg, it's solid. In the sea, it's a liquid. In the surrounding air, it's a gas. Solid, liquid, and gas are the 3 states of matter. Solids have a definite shape. A block of ice takes the shape of its mould. As it melts, it changes. The water spreads out and fills up the container. All liquids behave this way. They flow and find their own level. Gases spread out even more, filling any space available. The way solids, liquids and gases behave gives us clues about how their particles are arranged. In solids, the particles are in a fixed framework. They're held close together and vibrate. In liquids, the particles are still in contact, but this time they're free to move around. The particles in a gas are far apart. They move quickly and randomly in any direction. But how do we know the particles in a gas behave this way? Some of the evidence comes from looking at how smoke appears under a microscope. Smoke from the straw is injected into a small container. A lid keeps it in place, and a bright light enables it to be viewed under a microscope. It looks like tiny jittering points of light. When a straw burns, the smoke produced is mostly bits of carbon which haven't combusted. Under a microscope, they catch the light and appear to glimmer. But why do they randomly dance around? The movement of the smoke is caused by collisions with invisible air particles. As the air particles move about, they knock the smoke first this way, then that. Particles in a gas move randomly and quickly. Flowers produce pollen, which is a very fine dust, easily brushed off by a finger. Nearly 200 years ago, it was this dust which first gave us clues about how particles behave in a liquid. In the 1820s, the botanist Robert Brown was carrying out a study of pollen grains. He decided to crush the pollen and suspend the grains in water. But to his annoyance, the pollen continually jittered around. Today, we can best see this effect by looking at tiny carbon particles instead. A drop of carbon powder suspended in oil is placed on a slide and viewed under a microscope. Just like the smoke, the carbon is dancing around. Brown didn't know why this movement occurred, but we now believe it's caused by the motion of particles in the liquid. The carbon is being pushed around by collisions in the oil.